Hello, I'm Sai Sushma Gola, and the topic I have researched is Translation Validator for Optimizing Compilers. So, coming to the introduction, Translator Validator is a mechanism for verifying that when generating a program in compiler, the target code verifies the correctness of the source code. So the translation validation is one of the best approach that offers an alternative to the verification of translation in general and in the case of compilers. So with the consequences faced during conventionally evaluating the adaptation from the higher level source code to that of the lower level object code, which optimizing compiler does. So this compiler optimization upgrades memory in the code. So rather than verifying the translator itself, translation validation validates the correctness of each translation. It by generating a proof which is discussed further. So the correctness of modern optimizing compilers is challenging because it affects the size, complexity, and the accuracy, and it is one of the major problem being faced. So now to resolve this problem, we can rectify the errors by checking each logic when compiling with the respective source program. Now coming to the background. So to understand this topic more effectively, one must have an idea of translator role and the implementation of logic behind each instruction and the translation from the program target to the source program. So basically, when a translator does modifications a program from one language to the another language, so it is generally a programming language processor. It also important to know about the optimizing compiler, as it is a compiler tries to minimize or maximize some attributes of an executable program. Some of the most common requirements are to minimize a program's execution time, memory, and the power consumption, and most importantly the accuracy, which will affect the overall performance. So it is very important to know about resolving errors during the process of compilation, as this affects the whole process and mainly the outcome, as I mentioned earlier. So coming to the approach, there are various tools and techniques for implementing validation of translator for optimizing compilers of the source program. One such approach is that in order to resolve and to improve the exactness and accuracy of the optimizing compiler, we have implemented a tool called TVOC, which is Translation Validator for Optimizing Compiler. So this technique accepts a source program as an input and a target program. So these both comes to the intermediate phase. So this is a format which is used by the Open Research Compiler among various other compilers. As compiler performs optimizations in multiple steps, it is usually suggestible to break the validation into multiple phases, wherein each step uses a different proof rule. So there are two main phases of in the process of verification. The first one is verifies the loop transformations using the rule called permute, and the second phase verifies the rule called validate. And these verification conditions are validated using a theorem called CVC light. So coming to the phase 1, it is mainly focuses on reordering of transformations. So these transformations are very simple in order to when statements are executed. So reordering transformations are validated using a proof called permute. And two important mappings are required to implement the rules validate, namely a control mapping and a data mapping. The control mapping is formed by finding a correspondence between a subset of locations in the target program and a subset of locations in the source program. So these locations are called as cut points. So this is the other implementation approach. So using a translation validation infrastructure, the infrastructure observes the process of compilations with the semantics of the source program after each instruction, and this is done by implementing a prototype called GNUC compiler. So this prototype mostly handles reliable operations for optimization, such as It performs GCC operations like code optimization, common sub-expression elimination, and register allocation and code scheduling. Uh, so as a consequence of incompetence by the errors, it is important to know about the translation. Now coming to the conclusion, TVOC has some limitations. There are some optimizations and language features that are yet still need to be validated. So TVOC computes effortless invariance for each instruction from the data flow analysis. So there is a significant development required as this technique lack a few optimized features in the language and also the validation for the code generators. Uh, so it also uses a path relations for different points. So these are the references which I have used in researching the topic. Thank you.